Guys, we are still with this same problem. We just want to repeat the same problem for Centroid. We've done it before using a vertical strip. So I just want to quickly take us through the same problem with a horizontal strip. So we are told to calculate the point of intersection of those two graphs. So the two graphs are y equal to negative 2x plus 7 and x equal to 3 over y. So we need to calculate the point of intersection, then sketch the graphs and show the strip. So I want to calculate point of intersection this time. Maybe I can use a little bit of a different approach. So from here, I want to start by saying my equation 2, I will cross multiply to make it as xy equal to 3, so that I call it equation number 3. Then I will substitute 1 into 3. So I'm just using a little bit of a different approach to calculate point of intersection. So if I'm substituting 1 into 3, it means where there is y, I will then put that. So it will be giving me x into negative 2x plus 7 is equal to 3. Then if I open my bracket, it will be giving me I will get negative 2x squared, then plus 7x, then I take 3 that side, minus 3 is equal to 0. So from there, to solve, you can just substitute into your quadratic formula. Our quadratic formula will all know it to be negative b plus negative the square root of b squared minus 4ac on 2a. So that will be negative 7 plus negative the square root of 7 squared minus 4. Our a is a negative 2. Our c is a negative 3. All this on 2 into negative 2. So that is our quadratic. So if we now use our calculator, we are going to see the different values of x. So let's start with the first one. I've got negative 7 plus the square root of 7 squared is 49. So I get 49 minus, this is negative 8 times 3 is times negative 3 is negative 24. So that's 24. All that divided by, so it's basically the square root of 5, the 25, sorry, so that gives me plus 5 at the numerator. Then I have to divide that by negative 4. So if you divide by negative 4, that takes us to positive half. So our first value of x is positive half. Or if we do the same thing for the next value of x, so we know this part is 5, so you get negative 7 minus 5, so that is negative 12. All that divided by negative 4, so negative 12 over negative 4, that should give us a 3. So those are our values of x. So if we now substitute each value of x into any of the equation up there, we can get our corresponding value of y. So if we put x as negative a half there, negative 2 times positive a half, sorry, that gives us negative 1. Negative 1 plus 7 gives us 6. Or if we put x there as a 3, this is negative 6. 7 minus 6 takes us to 1. So you see we've still arrived at the same point of intersection that we got in the first method. So it's now time to sketch. So when we are sketching our point of intersection, direct us that we stay in the first quadrant. So in the first quadrant, I will start by quickly plotting my point of intersection. So I've got my 6 there, I can put my 1 there, because my y values are from 1 to 6. We're doing a sketch, we're not trying to scale. Then if I can put my 3 there on the x, maybe I can put my half there. Since the x, we've got 3 and a half. So we need the point a half and 6. It's there, and we need the point 3 and 1. 3 on the x and 1 is somewhere there. So looking at the two graphs, the first one, it's obvious that it's a straight line. To stretch a straight line, we just need 2 points, and we've got 2 points already. So these are our 2 points. Then the next one, from here, or from 3, you see it's a hyperbola. So the general formula for a hyperbola is xy is equal to k, where k is positive. The hyperbola stays in the first and in the third quadrant. So we're supposed to target first and third, but since the point of intersection they are all positive, we stay in the first quadrant. So we'll just link this to that. So that is our graph, or that is our sketch. So now we can shape the portion between the two graphs. So we've done this problem in a previous video. We used vertical strip because the shaded portion here can accommodate any strip, either vertical, as long as you keep on touching two graphs, or horizontal. So our target now is to repeat the same problem with a horizontal strip. So I'll go for a horizontal strip. So if I go for a horizontal strip, I can put it anywhere within the shaded portion. So that's my horizontal strip. So if I extend this strip out of the shaded portion, it takes me to the y-axis. So putting my dy there is just reminding me that if I go to the b part of the problem, which requires me to calculate an area, my area must start from A1. So as I was saying, once I put my horizontal strip, it's always important to extend it out of the shaded portion. You see it touches the y-axis. So my putting the y there is just reminding me that if I go to page number 4 of my maths basics formula sheet to look for the formula of my area, that formula will be a formula that ends with dy. So that is my formula from C to D. So from there, that formula also reminds me that on my graph, we need to see x1 and x2. So since I'm using a horizontal strip, x1 should be the graph on the right side of the strip, x2 is the one on the left. So on the right side of my strip, x1 is coming from the straight line, and on the left, x2 is coming from the hyperbola. So from the hyperbola, x2 will just be 3 over y. So as we were saying, once you've seen your formula with x1 and x2, it's reminding us that x1 must be on the right side of the strip, x2 on the left. So the left, it's easy because x is already the subject from the equation of the hyperbola. Then on the right, we've got the straight line. So in that straight line, I need to quickly make x the subject. So the straight line is y equal to negative 2x plus 7. To make x the subject, y will have to move to the left. Sorry, 7 will have to move to the left to meet y. So I get y minus 7 is equal to negative 2x. Then I can now divide all through by negative 2. So if I divide each term by negative 2, I'll get negative a half y, then plus 7 over 2, because if we divide this by negative 2, it's 7 over 2, that will be negative a half y. So that will be our x1. That should give us the value for x1. So it's negative a half y plus 7 over 2. So I guess with my graph now I'm done with my horizontal strip, so I can now calculate my area. So my area will be integral of x1. My x1 is negative a half y plus 7 over 2, then minus x2. My x2 is 3 over y. So I get 3 over y, then my dy comes there. And to read my c and d, which are the limits of integration, we see that our formula ends with dy, reminding us we must read along the y-axis from where we started shading to where we stopped. So our limit this time will be from 1 to 6 because we started shading at 1 and we ended at 6 on the y-axis. So from there, we can now integrate. So if I integrate, I get negative a half into y squared over 2 plus 7 over 2y minus 3 in y. So that's my integration from 1 to 6. So if I put my upper limit, I will know that this 2 and 2 will give me 4. So this is negative 1 over 4 into 6 squared, then plus 7 over 2 into 6 minus 3 in 6. That's my upper limit. My lower limit, I will substitute into the same equation. So if I put 1 there, that's 1 over 2 times negative 1 over 2. It gives me negative 1 over 4 plus 7 over 2. If I put 1 there, minus 3 in 1. So all I need now is get to my calculator. So in my calculator, I see that 6 squared is 36 divided by 4, it's a negative 9. 6 over 2 is 3, 3 times 1 is 27, so I'm getting 27. 3 times, 6 divided by 2 is 3, 3 times 7 is 21, so I have 21 minus 9, since this was negative 9, then minus 3, then 6. So that is the information in my calculator. So my area here is, or the first bracket is 6,6 to 5. Then I do the same thing here. So I'm having 7 over 2, that is 3,5, minus 0,25 for negative 1 over 4, then minus 3, then 1. So the other part gives me 3,25. So if I then do this subtraction, I will see my answer 6,625 minus 3,25. That gives me 3,375. For those who followed the other video on this same problem, that was the exact answer we got for the area. That's 3,375. So that's just to show to you that if you can get a diagram where the shaded portion can accommodate any strip, then whichever one you use doesn't really matter, as long as you are good with the techniques of integration. So we can now go to the last part of the problem, which requires us to calculate the x-ordinate of the centroid described in A. So they make life easy by taking you directly to the x-ordinate. As I'll keep saying, if they wanted you to struggle, they will say calculate the distance of the centroid from the y-axis. So you see we got to the same area as before. So now we go to the last part where we need the x-ordinate of the centroid. So as an NSET student, all you need to do is go to page number 5 of your formula sheet. There is a subtopic there called centroid. If you look at the formula for x-ordinate of the centroid, that is the definition, where the area, the denominator, we've got it as 3,375. What we need now is the area moment about the y-axis. So the area moment about the y-axis, the definition is there, also on page 5 as the integral of r dA. So I'm now going to develop this formula using my diagram. So usually my dA corresponds to the formula for the area I've just used. So I'll copy down that formula. So I'll have the integral, I will leave space for my r, I'll take x1 minus x2 dy. Then for my r, to get it right, I must go back to my graph. I will start from the center of my strip and I move in a straight line to the y-axis, then I'll be able to define my r. So I'm going back to my diagram. So on my diagram, see my strip is a horizontal one. I start from the center of my strip and moving in a straight line until I meet the y-axis. So even in the other video, we still move horizontally. So normally when you move horizontally, your arrow is supposed to be x because it's parallel to the x-axis. But because your strip moves in the same direction as your arrow, this time our arrow will no longer be a simple x, but the midpoint, or what we call the average of the two graphs that the strip is touching. So here, my arrow is supposed to be x1 plus x2 over 2, which I've explained before, that for me to get x1 plus x2 over 2, I'm treating that strip as a straight line with x1 on the left, x2 on the right. Arrow is always coming from the midpoint, so it's like we are calculating the coordinate of the midpoint. That's where we get our x1 plus x2 over 2. So, but the easy way to understand it is that each time you go back to your graph and find your arrow and you move in the same direction as your strip, then make sure you take the average of the two graphs that the strip is touching. But if you don't move in the same direction, if your movement is horizontal, you use x. If your movement is vertical, you use y. So in this particular case, our arrow is x1 plus x2 over 2. So if I come back to my diagram, I'll be using x1 plus x2 over 2 in the place of r from 1 to 6. And now this 2 at the denominator goes out as a half. Then the other one will give me the difference between two squares, because if I take a plus b into a minus b, I should be getting a squared minus b squared. So that is it. x1 plus x2 into x1 minus x2 should be giving me x1 squared minus x2 squared. So that is it. Then I can now substitute my values for x1 and x2. So x1, the graph was a half of negative half y plus 7. So that was my x1. You still remember? Our x1 was negative a half y plus 7 over 2. In other words, you see that 2 is common at the denominator. So I can call it negative y plus 7, all that on 2, or better still, 7 plus y, 7 minus y, all that on 2. I'm just trying to take you through this so that if I'm squaring this, I can easily square like that, then I square the numerator and square the denominator, avoid struggling with negative numbers. So in this situation, my x1, I'll be writing 7 minus y over 2, all this square. So it's the same thing as what I've done here. You can see it there. Then minus the other one, x2 is 3 over y. I also square that. So when I square my 7 over y, it means I'll just square 7 minus y, and I've explained that to square numbers like this is very simple. You can write your 3 terms. I take 7 and square it, I get 49. I take negative y square, I square it, I get y square. Then in the middle, I take 2 times 7 times negative, gives me negative 14y. So that's the reason why I put it that way. So this will give me 49 minus 14y plus y squared all over 4. If I square the denominator, it gives me 4. Then minus, if I square 3, I get 9 on y squared. So this is what I get, but we know very well that you can't integrate y at the denominator if the power is not 1. For the area, we left it there because the power was 1. But immediately the power is different from 1, it moves up. Then for each of these terms, I can divide each by 1 over 4. Since 1 over 4 is a common factor. So this gives me 49 over 4 minus 14 over 4, which is 7 over 2y plus 1 over 4y squared, then minus 9y to the power negative 2. So this is the integral I will be doing. So with this integral, I can then continue y squared on 2 when you integrate y, then plus 1 over 4. If you integrate y squared, you get y cubed on 3. Then plus, or call it plus because when you integrate y to the power negative 2, you add 1 there, it will give you y to the power negative 1. Let's put it there, divided by negative 1. With this negative, this 9 becomes a plus 9, then your y will go to the denominator to become y. So that is what we get from 1 to 6. So we can now substitute our limit. The upper limit means we put 6 there, so you get 49. 49 on 4 times 6. Then minus 2 times 2 there is 4, so I'll get 7 over 4 times 6 squared. Then plus 4 times 3 is 12, so I'll get 6 cubed on 4 plus 9 over 6. That's my upper limit. Lower limit, if I put 1, I'll get 49 over 4 minus 7 over, maybe I should take the lower limit down. There is no space for that. So that will be minus a half into, I'll get 49 over 4 minus 7 over 4, because if I put 1 there, 2 times 2 is 4, then this is 12. If I put 1 there, I get 1 over 12, and if I put 1 there, I get 9. So that is it. So I'm going to do my upper limit minus the lower limit on my calculator to see what I get. So if I go to my calculator, it might take me a little bit of time, but I will try to go through that. So that is 49 times 6, all that on 4. Get 49 times 6 on 4. So the first one gives me 147 over 2. Then the next one is 36 squared is 36. 36 divided by 4 is 9. 9 times negative 7 is negative 63. That one. Then I'll get 6 cubed is 216 divided by 4. That gives me plus 54 plus 9 over 6. In bracket a half again into 49 over 4. I'm just trying to put it in a way that I can easily handle. So in there, I will now be able to handle that. So I'm getting 54 minus 63 plus 147 on 2. Then plus 9 over 6. So that is what I get, times a half. So the first part gives me 33 from my calculation. Then I will do the same thing here, 49 on 4 minus 7 on 4 plus 1 on 12 plus 9. The second part gives me, then I multiply by half times 1 on 2. So that gives me minus 235 over 24. So I will simplify that to see what I get. Minus 235 on 24. That takes me to 23,208. So therefore my center of my centroid will therefore be x bar being 23,208 divided by 3,33375. So I'm going to do that division, 3,375, to see if it takes me to the same result. There is a mistake. So guys, as we have done it, you will see that 23.208 divided by 3,375 from my side is giving me a very big number, which is around 6, whatsoever. So with this it immediately tells me that there is a mistake somewhere, because if I go to my diagram and I want to look at my x-axis, the diagram on the x-axis starts from a half to 3. So there is no way that the centroid can be between outside of this interval a half to 3. So these are the kind of things that if you do them and you find out that your answer is not corresponding, you have to quickly try to verify where you made a mistake. Because from my side, I'm obvious there is a mistake. So if I'm checking through the part, I will start by where I did my integral. You will see that here I got 49/4. I'm seeing it there. 7/4. I'm seeing it there. This is supposed to be 1/12. So you see, I can pick up where my mistake came from. That I made a mistake somewhere. So at this point where I put a 4, that is certainly what created trouble for me in the first part. Then here is 9/6 when I put the value of y here. And it's even obvious because in the second part, you see that there is a 12 there and I'm getting a 4 there. And here there is a 4. So I'm suspecting that this is where the problem is. Because my answer is telling me something that does not make sense. So I'll go here, I will replace this by 12, and I will recalculate this value of 33, and then see whether will it take me out there. So when I did this calculation here, this one gave me 147/2, then this one gave me -63, so it means this calculation here should be the person with the problem. So if I take 6 cubed, it gives me 216, sorry. I divide by 12. I guess last time I divided by 4. So if I divide by 12, it gives me this time 18. Then I get my 9/6. So I will repeat this portion. And obviously this 33 will no longer be 33. So I'll get 147 on 2. Then minus 63 plus 18 plus 9 on 6. That gives me 30. I multiply by a half. That gives me 15. So this is supposed to be 15. So if I now take 15 minus 235 on 24, that takes me to 5,208. So this is obviously getting me closer to what I want now. It's 5,208. So here I should be having 5,208. So if I divide 5,208 by 3,375, it takes me to 1,543. So guys, with this one, I believe so much in that answer, because when I look at my graph, along the x-axis, the shaded portion along the x-axis lies between a half and 3. Therefore, my x bar or my x coordinate of the centroid must be between a half and 3. So you can see how in the exams you can make a mistake on the centroid, and if you already understand what is happening, you can still manage to sort yourself out from that mistake. So I guess with the 2 methods, they help you. Thank you very much.